Hey guys, this is Yoru. In the last lecture, we have learned how to analyze the velocity of a slider crank mechanism. In this lecture, you will learn how to analyze its acceleration. In acceleration analysis, our goal is to determine the acceleration vector q double dots, which consists of 4x double dots, 4y double dots, and 4 theta double dots. Now let's quickly review what we have learned in the last lecture. In the last lecture, we first differentiate the constraint equations with respect to time once, and then solve the equations shown here to determine the velocity vector q dot. Since from kinematics, we know that by differentiating velocity with respect to time, we can get acceleration. So now we will differentiate these equations again with respect to time. The differentiation results are shown here. By solving these 12 equations, we can determine the 12 unknown acceleration, which is our goal for acceleration analysis. Similar to velocity analysis, we are going to express these equations with matrices and vectors so that we can solve them using computers. First, we move the terms that are not related to x double dot, y double dot, or theta double dot to the right-hand side. For example, in these equations, these two terms don't have x double dot, y double dot, or theta double dot. Therefore, we move it to the right-hand side. After this step, we will have 12 equations like this. Next, if we express these 12 equations with matrices and vectors, we will end up with the Jacobi matrix J times the acceleration vector on the left-hand side. As for the right-hand side, we will end up with the vector gamma shown here. So now we have obtained the equations J times Q double dots equals to gamma, where Q double dots can be solved by taking the inverse of J. Note that if the driving link of the system is rigid body 3 instead of rigid body 1, the procedure is still the same, except that 12th row of the Jacobi matrix and gamma vector should be replaced by the row vector shown here and the term shown here. So this is the end of this lecture. In the next video, we will show you how to use MATLAB to analyze the displacement, velocity, and acceleration of this slider crank mechanism, and visualize its motion through animation. See you next time.